Thank you. Well, good morning, everybody. Yeah, I represent Metamaterials, and we're developing a discrete platform, specific proprietary technologies for large area lithography, similar to the previous speaker in a sense, but I guess where we differentiate is that to a certain extent, we have roll-to-roll manufacturing of these films, so the large area, allowing the manufacture of these nanostructures to be carried out in a very cost-effective manner. So each platform that we have employs massively parallel patterning scheme designed to be scalable in these large areas of either rigid substrate materials or rolls of flexible film. And in certain cases, we use phase shift masks approach to actually pattern them. And in others, we use a new type of cast plasmonic printing, all allowing for the creation of structures with feature sizes down to about 50 nanometers. Metamaterials are complex structures, as we've just learned, and patterned into conventional materials such as metals or plastics in ways that perform special functions, such as transparently blocking a specific color of light, for instance, in one of our products for reflective glasses to prevent people from laser strikes, etc., or performing multiple optical functions in, say, a lens, which we're also working on. So what I'd like to do today is just zero in on just one of our platforms, NanoWeb, in the time available, and several revolutionary printed electronic applications that NanoWeb enables. So our NanoWeb is a metal mesh, and it's configured as a transparent nanostructured conformal wire mesh with approximately 500 nanometer line width, with very superior electrical and optical properties. And it can even be laminated onto glass curved surfaces. And I'll come on to explain how we've applied it to ophthalmic lenses for a number of exciting applications. ITO has high electrical conductivity, granted, and has good optical transparency, and it's chemically stable, but it suffers from very high cost and limited supply of indium. It's fragile in many cases, inflexible, and is costly to deposit, especially as you get down less than 20 ohms per square, which a lot of our customers want for some of the automotive applications I've come on to. NanoWeb, however, has all the electrical performance benefits of ITO, and as you can see here, NanoWeb technology clearly demonstrates a superior transparency and sheet resistance performance, which in many cases can't be attained by ITO. It supports precision, high resolution, and high yield patterning. And this is because we're patterning literally at the lithographic level at source. And so we're able to pattern in certain types of features and new types of applications. For example, in a show recently, a couple of weeks ago, we demonstrated a 5G antenna that can receive high bandwidth, totally transparent into the optical lens. So by patterning it at the same time that we're making the NanoWeb into the application structure, we in fact get all that for free. There's no need, unlike ITO, to go back and do that. In this application, NanoWeb, as I mentioned, enables the smart glasses for 5G and 6G antennas. We can also commit to putting in eye tracking and anti-fogging filters, all to be integrated. Our goal here for customers in all-day wearable glasses. And these are ophthalmic glasses. And you'll notice that the 5G patterned antenna in the black frame glasses here is totally invisible. You literally go right up to it, move around, and you cannot see it in there because of the resolution of the patterning. So the casting of these electronic devices in curved lenses also requires precision alignment. And as we fabricate and cast these lenses, we're able to actually align these functional films very accurately, either for display applications or antenna applications like the one demonstrated. Here we've laminated our NanoWeb to be an EMI shield in the door of a microwave oven. And we're actually sampling these now as demonstrations to a number of manufacturers. We can scale this using our roll-to-roll process into full-size ovens. And we even address the smart oven application space where you not only have a microwave built in, but you also have a convection oven and a steam oven at the same time. And it's only with this highly transparent nanoweb as an alternative to the traditional microwave perforated mesh that you have at home that you're able to do that, because clearly when you're using conventional convection oven, you want to be able to see how the cooking is proceeding and to time it in that respect. So nanoweb is a key enabler to create total transparency in this consumer category. Here, nanoweb's attached to a building where it can enhance 5G and 6G signals and high bandwidth signals.
You've got 1 minute.
Thank you. And it's a totally passive solution where the functional film reflectivity is equal that to a solid metal sheet. And finally, in ADAS and autonomous vehicles, which depend on cameras and sensors to see their surroundings, we can use nanoweb as an active heater in that respect to heat and demist and defog, etc. So that really gives an overview of one of our category products. And I encourage you to entertain any questions or comments with regard to either this or some of our other products at Metamaterials. Thank you so much.
Thank you so much, Jonathan, for the excellent presentation. So I want to say that Metamaterial is our gold sponsor, actually, so thank you very much. And they do have a booth. So if you want to meet Jonathan and some of his colleagues, maybe, please visit Hall 6. So go back to the floor plan and click on their logo at Hall 6, and then you will find their booth.